Hey everyone, Dr. Collins here. In this video, I'm going to show you how to do a single sample t-test using SPSS. I'm actually going to give you an example research question that you can answer using a single sample t-test, as well as some made-up data to help us answer a research question. In this video, I'm actually going to go through two different examples of testing a research question using a single sample t-test. And this is just to demonstrate the way that we're going to interpret our analysis and write up our results when we have a significant finding. Also, what to do and how to write it up when we have a non-significant finding. Let's first discuss the basics of when we should use a single sample t-test in the first place. So first off, we are going to use a single sample t-test, which is different from an independent samples t-test or a related samples t-test. A single sample t-test is a different type of statistical test. And we're going to use this type of test when we're just comparing a sample mean. So our data from a sample we want to compare to a known population mean. You see that the word known is underlined here because this is a really important distinction between some of the other tests that you could possibly use in statistics. So we're going to do a single sample t-test when we want to compare our sample to a known population mean. One other thing about when to use a single sample t-test is while we do know the mean of the population that we want to compare our sample to, we do not know the population's standard deviation. So we'll also use a single sample t-test when we do not know the population standard deviation. If you did know the population standard deviation, you would use a completely different test altogether. So if you did know the population standard deviation, you would not use a single sample t-test. Instead, you would just do a z-test. So if you have that information, do a z-test if you can. So it's only when you do not know your population standard deviation would you use a single sample t-test. And with the single sample t-test, it actually uses the sample standard deviation to try and estimate that unknown population standard deviation value. So again, a single sample t-test is just a replacement for when you do not have that population standard deviation, but you do have a sample that you've collected and you want to compare it to a known population value. So here's an example of what a research question might look like that would involve doing a single sample t-test. In this research question, we have a researcher who wants to know whether students who've taken a statistics class will have a different score on a standardized math test compared to the normal population of test takers. That population of test takers is known to have a score of 150 on average. So that 150 is the population mean that's known, and really if you're dealing with this in a class, you're probably going to be given the population value, that population average that you want to compare your sample to. So we're given the value of the population mean in our question, and we're asked to use sample data and an alpha level of 0.05 to test this research question. So the next step you as a researcher would have is to actually collect data to test your research question. So you collect your data from a sample, and here's an example of what your data might look like in SPSS. Now that we have our data that we've collected from a sample, so again, this is a sample of students who have taken a statistics class, and we want to see how their average on the standardized math tests compares to that population value that we're given. So this is our sample of students who took a statistics class and all of their scores on that standardized test that they took. And to do the single sample t-test, we're going to go ahead and start on these drop-down menu options. We want to select the Analyze drop-down option. From there, we're going to select Compare Means. And then from there, we want to take that one sample t-test option. So go ahead and click on that, and you should get this pop-up window here. And your version of SPSS might look slightly different. I'm using version 27. So most of them will look kind of the same in the output that you give, but just know that right here, this might look slightly different if you're using a different version of SPSS. But the same general setup is going to apply regardless of which version of SPSS you're using. So now that we have our pop-up window open, we want to find the variable that we're looking for in our variable list. Since I only have that one variable set up in this data set, I just have that standardized score values of everybody in the stats class. It's pretty easy to find what I was looking for. However, if you were working with pre-existing data, you might have a whole list of variables that you're looking through. And one way that might be easier to look at your variables or trying to identify the ones that you're looking for is to right click in this box here and choose this option, display variable names. And that will show you the shortened name. Sometimes it's just easier to find your variables that you're looking for that variable name rather than the variable label, which might be longer. So either way, you want to find the variable you're looking for, move it over here into the test variable box. And then the one other major thing you want to do is make sure to change this test value number. Let me reset this so you see the default options look like this. And when you move the variable over, that test value will be 0. However, we want to make sure to change that because the test value represents whatever population mean you want to compare your sample to. And so having 0 is going to be really wrong in this situation, because if you remember back when we were given our research question, we were asked to compare our sample mean to the population value, which was 150. With this default option of 0, it would compare our sample mean to 0, which is not what we want. We instead want to compare how our sample compares, really. So we want to compare our sample to the population value, which was 150. So whatever that population value is that you're wanting to compare your sample to, that's the number you're going to enter right here. So you enter the actual number of your population mean into this test value box. The only other thing you're going to want to make sure to do if you're using SPSS version 27, it will show this estimate effect sizes option. I don't think this checkbox is available in some other versions of SPSS, some of the older versions, but I'm going to show you a workaround if you don't have that box. But if you do have that box, go ahead and make sure it's checked, and that's it. So we'll just click OK from here. So once you run your analysis, it should give you your output in a new output window, and that will show you all of the statistics associated with that test you asked it to run. So I'm actually going to go ahead and copy and paste these tables into a PowerPoint to make it a little bit easier to go through. So here is our SPSS output copied and pasted just into a PowerPoint slide. One of the first things I recommend looking for is looking for your p-value, which is also labeled as your sig in SPSS. The sig is your p-value, but the main reason I say to look for that first is because that will tell you how to interpret this analysis. So first we're going to look right here, our sig value. I kind of highlighted two things there, but the sig value is right here. It is that number 0.198. So the sig value tells you whether this test was significant or not. Essentially what we do here is we compare that sig value, which sig is our p-value. It's our probability of getting this difference just due to chance alone. So we're going to compare this number to our alpha level. If we find that our sig value is less than our alpha level, that would mean our test was significant. If our sig value is greater than our alpha level, that would mean our test is not significant. So here we see our sig value is 0.198. And if we compare that to the alpha level we are given at the beginning of this research question, we are given that alpha level of 0.05, which is also the default alpha level. So using that alpha level of 0.05, we see that this number is not less than our alpha level. So 0.198 is not less than 0.05, which would mean that this test is not statistically significant. Meaning that the difference we identified here between our sample mean and the population value, it was not big enough. That difference was not big enough to say that it couldn't just be due to chance alone. So essentially, the difference we found between our sample and the population was not big enough to say something's going on here. And so if we were to write that up in our results section, so I labeled it down here as a conclusion, but really this is the part that you're going to write in your results section to say what you found in your analysis. So since we found that this test is not significant, we would say something like this. So students who took a statistics course, and then you see I inserted the mean there. That is our sample mean. So this value is our sample mean, which is why we use the capital M. That's APA style. We'll use capital M to represent our sample mean. And you can see I got that from up here in this one sample statistics table here. So I reported my sample mean, and do make sure that you're rounding to two numbers after the decimal point. So I rounded that 0.1667. I rounded that up to 0.17. So make sure you're rounding to two numbers after the decimal there. But the students who took that statistics course did not have a significantly different score on the standardized math test compared to the population of test takers. You see that I also put that population mean that we were given. I put that in parentheses there too, so that when people are reading our results section, they know what value we were comparing our sample mean to. We were given that number in our actual question, so that's where the 150 came from. We were given that in our question. But we want to make sure to report it using APA style notation, which uses that mu to represent a population mean. So I got that number from the actual question itself, and then let me show you where I got the rest of these numbers. So we're going to report the results of the t-test by saying t, which is italicized, and then we want to put the degrees of freedom in parentheses next to that t. You notice there's no spaces around the parentheses, it's just right next to it. And the degrees of freedom I got from up here in the one sample test output. So we'll put that number associated with the degrees of freedom in the parentheses. Then I have a space, and then the equal sign, another space, and then you see I have the value for t. So that would be the actual calculated value for t. That appears there in your one sample test box. So that's your number for t. Again, we're going to round it to two numbers after the decimal place. And then finally, we want to end this sentence by saying NS. Whenever we have non-significant findings, we're just going to go ahead and end that sentence with NS. We don't say anything else. We use the NS notation to notify the reader that that was a non-significant statistic. So this is an example of how to write up your results when you have a non-significant single sample t-test. Let's go through another example. And in this second example, we want to see, it's a very similar question, but in this second research question, we want to see if students who took a geometry class would actually have a different score on the standardized test. And again, we're comparing the students who took this geometry class to the population of test takers who have that average score of 150. We're still going to use that same alpha level in order to test this research question. So now, again, as a researcher, it's your job to go out and collect the data from students who took a geometry class to see what those students' scores were on this standardized test. So here again, I have my made-up data, but this is consisting of a sample of students who took a geometry class and how each of those students scored on this standardized test. So here are my data, and again, we're going to do the analysis in the same kind of way by going to Analyze, Compare Means, and then One Sample T-Test. And so again, we're going to find our variable in this list and move it over into the test variable box. Again, don't forget that we need to change this number here for the test value. So again, we're going to enter in the number for the population mean. And that we were given in the actual question. We were told that the population mean of test takers have a score of 150. Again, if you're using version 27 of SPSS, make sure you've checked this estimate effect size box. And then from here, we'll click OK. Our output's going to show up in an output box. And again, I'm just going to go ahead and copy and paste this over to PowerPoint to make it easier to look at. And here's what our output looks like for this analysis. So again, we're going to make our initial decision about this test by simply just looking at that SIG column that tells us what our p-value is for this test. So again, this is the main kind of column we want to look at first is this SIG column. That tells us what our p-value is. And again, we will compare that number to what our alpha level was, which will always just use a default of 0.05 unless you're having a more strict test. So that's really determined by the researcher of what your alpha level is, or if you're in a class, you will probably be told what your alpha level is. But by default, we usually take an alpha level of 0.05. Same with in this question, it told us to take that alpha level. And again, anytime your actual p-value or that SIG value is less than your alpha level, you will reject the null hypothesis, which essentially just says, yes, this difference is big enough to say that it's significant. So this difference that I found between my sample mean and what the population value was, that difference is big enough to say something is going on. So that would be significantly different. So here with this SIG level of 0.012, that indeed is less than an alpha level of 0.05. So we would say in this situation that our sample is significantly different than the population we are comparing it to. So the way we would write this up is students who took a geometry class, again, I put the mean of this group here in parentheses after I mentioned them. And again, where I get that mean from is up the top here, where we have our one sample statistics, and it tells us the mean of our sample up at the top. Also, one thing to note is it also tells you how big your sample was. So we had 30 people in this sample, and the mean of those 30 people was 156. And here we would say they had a significantly different score on the standardized math tests compared to the population of test takers. Again, that value we're given in the question was 150. And still we're going to say T and then our degrees of freedom in parentheses next to it. And here we got our actual calculated value for T is located up here in this one sample test box. So again, we're rounding it to 2 numbers after the decimal point. And then what we want to say is what our p-value was. So in the last example right here, we wrote NS, but since this was significant, we instead would write what our p-value was. And that's going to be the exact value that is your SIG value. So your SIG is your p-value. And the way that we write that in APA style would just be p is equal to, and then you can write whatever that value was. There is an exception, which I'll talk about in a second. And then here, since we have in SPSS version 27, it does give us the effect size, which is measured by Cohen's d. And I'm going to revisit this in a second in case you're using a different version of SPSS that does not give you effect sizes. I'll tell you what to do in just a second. But if you do have version 27 and it is giving you the effect size, you'll see down here in this, this box at the bottom, it has a row for Cohen's d. And we're going to go ahead and take the value that's in that point estimate column. That is our Cohen's d. And we're going to want to report our Cohen's d, or our measure of effect size. Anytime we do have significant results, we're going to provide that measure of effect size. You'll notice in the last example I went through where it wasn't significant, in that case we should not report our Cohen's d if we did not have a significant finding. Because basically you didn't find a significant effect, you're already saying there is no effect. So you wouldn't say what size that effect was because you already said there isn't one. So we would only report effect size if it is indeed a significant effect. So I wanted to mention just one other thing about your p-values. So remember, first off, your sig column in SPSS, for some reason, you know, the SPSS program always labels your p-value as sig. So remember that sig is your p-value. So sig is always the column that tells you what your p-value is. And anytime you have a p-value that is bigger than your alpha level or bigger than 0.05, at the end of your sentence, you're just going to write that NS. So that would be that situation of having non-significant findings. If ever you're finding that p-value, that sig value is anywhere between 0.001 or 0.05, then we would report the exact value of p. And so in this case, we had our p-value was equal to 0.012. And we're going to report the actual number in our results section, that 0.012, if our p-value is in between those two values. If your p-value happened to be less than 0.001, so this sometimes will show up in SPSS as like 0.00 significance. So if you ever have a significance level of 0.00 in SPSS, if that's what your value actually is, that is saying that there's no probability of that happening at all, which actually is not possible. So instead, the way you would write that in your results section is to use this value of p is less than 0.001. So those are the only three options that you have of how to essentially write your p-value or NS in your results section. And finally, I wanted to give a side note just for those of you who might be working with an older version of SPSS that does not automatically calculate the measure of effect size for you. If you're in that situation, you actually can very easily calculate Cohen's d on your own. So if you did have a significant finding, you can calculate Cohen's d very easily with the information that you're given in your SPSS output. So again, this would only be in the situation where you weren't given this box of effect size. If you have an older version, it didn't allow you to ask for effect size, then you wouldn't have that box. And so only in that situation would you calculate Cohen's d by hand, which again is a very easy calculation to do. So to calculate Cohen's d by hand, you just take what your sample mean was, and that is in your box right here. So the mean of your sample, and then we're going to subtract from it the mean of your population. This actually will show up also in your SPSS output, but it is that value that you entered as your test value. So whatever your population mean was, that is the number from you. And then finally, you'll divide it by the standard deviation of your sample, which also is in this box up here at the top in your one sample statistics box. So you see I just plugged in all of those values. So your sample mean in this case was 156 minus the population mean in this example was 150 and divided by your sample standard deviation, which was 12.21. We're taking the absolute values of that to get Cohen's d. Cohen's d doesn't matter if it's positive or negative, it just is reported essentially as a positive value regardless of whether your calculation was positive or negative up here. You know, we're just going to turn it to positive even if this was negative. So our Cohen's d, when you do this calculation out, you should get this value of 0.49. So if you cannot ask your version of SPSS to give you Cohen's d or a measure of effect size for you, you can just use this simple formula to calculate that value of Cohen's d. And you'll see that indeed that value is exactly the same as it was when I asked the program to do it for me. So that should help you identify your Cohen's d if you aren't able to ask the program to do it for you. So that is an example. The second example tells you how to write up your results if you have a significant one sample t-test. And hopefully that video is helpful. Thanks. Bye.